Now we're going to talk about Newton's first law of motion. Everybody has heard Newton's first law of motion, whether they understand it or not. It's probably the most universal law that most science students hear about. And it says that an object at rest will remain at rest, and an object in motion will continue in motion, moving at a constant velocity unless it's acted upon by some outside force. And you know, that says an awful lot, and it says an awful lot to understand. But it's actually pretty easy to understand if you just think about it a little bit. If I have a diagram here, and what the diagram shows, it shows basically a cross-section of a valley. The top of the valley on each side. And I'm going to take this ball and I'm going to set it up here at the top of this valley. And if I were to release this ball at the top of this valley, you would expect that ball to roll down the valley and come up to this side of the valley over here. And obviously, you know intuitively that that ball would not go up to the same height on the left side of the valley over here. And when it rolled back down again after it stopped, it wouldn't go up to even that height on the other side, on the right-hand side. And as it rolled back and forth in the valley, it would go less high each time until finally it would stop at the bottom of the valley. And if I were to ask you why this ball, when it was released from this height, right here, why that ball wouldn't roll up to its original height on the left side of the valley, you would probably say it's because of friction. Sure, and you're right. When you release this ball, there's friction that acts between the surface of the ball and the valley floor. And so it takes some of the energy away from that ball as it rolls each time. And so as it loses energy, friction will eventually cause it to stop right there. Now, let's just suppose we could somehow magically take all of the friction away. If we took all of the friction away, and I pose the same question, if I release the ball, how high will it reach on the left side of the valley? Well, you know, if I took the friction away, the obvious answer would be it would roll up to its original height on this left side of the valley. And so if I took the friction away, took that force away that was robbing this ball of energy, it would eventually just roll back and forth all the way up to each side of the valley every single time it rolled, and it would do that forever. It wouldn't stop. That's the logical thing to say. Well, we can take that same valley, and instead of having two high sides, what if we were to take this valley and stretch one side out level? Lay one side down so that one side is level. Now if we take that ball, in the real world, if we say, if I release this ball right here, you know that that ball would roll down the valley, it would gain velocity, it would accelerate as it moved outward, and it would roll out, and eventually it would stop. And if I asked you why that ball would stop, you would probably say it would stop because of friction. But now, if I ask you this, what if I could magically take the friction away? If I could magically take the friction away and let that ball go, it would roll down the valley, it would gain velocity, it would accelerate, and when it reached the flat part of the valley, it would continue moving at a constant velocity forever, and it wouldn't stop until we applied some outside force to it to cause it to stop. And that is the essence of Newton's first law of motion. In the absence of all external forces, take away friction, take away air resistance. In the absence of all external forces, An object's natural state is to stay doing exactly what it was doing before you added a force to it. So an object at rest will remain at rest unless you apply a force to it to accelerate it. And an object in motion will continue in motion, moving at a constant velocity. That means not speeding up, not slowing down, not changing direction, unless it's acted upon by some force, some outside force, such as air resistance or friction. So if you take those away, Newton's first law will cause this object, or say this object will move at a constant velocity forever, unless it's acted upon by some outside force. And that's the beauty of Newton's first law. It really does work for real objects. In space, where there's no atmosphere, no friction, objects that are moving continue moving forever at a constant velocity, unless some force acts upon them, unless they get near some planet, unless they run into something. They follow Newton's first law of motion. An object at rest will remain at rest, and an object in motion will continue in motion, moving with a constant velocity forever, unless it's acted upon by some outside force. And that idea that an object will continue to do what it's already doing, that idea that an object will not change what it's doing without the application of some outside force, has a name. It's what is called inertia. Inertia means that an object at rest will remain at rest, and an object in motion will continue in motion. And to change that, you have to apply a force, some outside force.